Hello everyone, thank you for coming to my talk. I'm Federico Tenga from Bitfinex. At Bitfinex we have a team that is working full-time on RGB development with the goal of trying to boost the development of the RGB ecosystem. And so today we're going to talk, first of all, a little bit on RGB in general to make sure that also people that don't already know about RGB, they can be up to speed. And then we will see a bit about what can be built on top of RGB, what has been built on top of RGB, and we will also have a little demo in the end. So first of all, let's try to have a little bit of understand the why part. First of all, maybe, what is RGB? RGB is a tokenization protocol on top of Bitcoin. So the goal is to be able to have tokens on top of Bitcoin compatible with the Lightning Network. So why do we need any of this? If we look at stablecoins, which is the most popular kind of token that we have nowadays around, they have like billions in market, hundreds of billions in market capitalization, and tens of billions in daily volumes. If you look at the stablecoin market, we will see that it's a very big market, and it's 99.99% running on altcoins, such as mostly Ethereum, Tron, and a bunch, lesser scale, a bunch of others. So looks like the market is pretty happy. I mean, there is a pretty big market, and it's running on altcoin, and the market is pretty happy with that. So why do we need something different? So let's look a little bit at the problem that there are if we want to use altcoins as a layer to move tokens around, and in this case specific stablecoin, but also other kind of tokens that maybe now they are a bit less relevant, but may become more relevant in the future, such as security tokens and other stuff. Altcoins have a few problems. First of all, they have a quite low level of decentralization. So most of those altcoins, they are basically controlled by a quite small set of validators, meaning that those validators, they have potentially quite a lot of power on the network, both to censor, both to make it stale that like nobody can transact anymore, or even to change history, past history in some cases. So as a consequence of that, we have less security because those validators can be evil, so they can try to steal money, they can be forced to do stuff by government, they can be hacked, they can do mistakes. So those are all vectors of attacks that jeopardize the security of the network. They're not really reliable long term. I mean, every year there is a new fancy altcoins. Every year some altcoin that was fancy in the past kind of go out of use. And we cannot really know if any of them will still be around and reliably working in 5-10 years from now. Maybe yes, maybe like Ethereum and Tron will still be around for a long time, but I don't think anyone can be so sure about that because of the low level of decentralization, and also a bunch of other problems that they have in their the way they are developed and the overall proof of stake architecture. So it's not something that you can say, okay, I build a solution right now on Tron, and I'm gonna put billions on that, and this is gonna work for 20 years. I mean, it works good now. It works good enough now, I would say. But we cannot be so confident that they will work in the long term. They are not really scalable when they become popular. They're very scalable when nobody uses them, but when people start using them, then they suffer scalability problems because they start having a lot of transaction happening on the network. So they either like the cost of transacting on those networks can go up significantly, or the cost of running a node the cost and the complexity of running a node can become very high, so very few people run a node, which adds another level of centralization. Everybody relies on a few nodes, on third-party nodes to have a view on the blockchain. Those nodes, they both they could lie, or they could also just, I don't know, like crash because of hardware requirements. So a lot of things can happen that adds other layers of vector of attacks and unreliability. So there are a bunch of problems which may manifest on those networks in the near future or in the medium to long term, depending on external factors. But yeah, there are definitely issues that for now they are not so bad that they prevent people from using them. That is something to be aware of. So why then the market likes altcoins if they have so many problems? First of all, because they are often able to make such trade-offs that they compromise security and decentralization in order to offer cheap fees, so very low cost of transacting. And sometimes even by doing all those trade-offs, the cost of acting actually can go up quite significantly. So networks that were very cheap in the past, they become less cheap recently, but still, I mean, they promise cheap fees, and that's also why you have such turnover. When someone becomes successful, the fee goes up, then another one comes, is the new fancy one, he has lower fee, everyone goes there, and then the cycle repeats. They are short-term, like a lot of players in the market, they are short-term oriented. I mean, for example, I don't know if I just need to receive some USDT today and spend them next month. I mean, I don't really care if the Tron network or the Ethereum network will work in 5 years. I just need it to work for a few months for my operation. And so yeah, a lot of market participants, maybe they just don't really care that much about long-term implication. And also, like, yeah, those altcoins, they all have issued a native token through ICO or other processes. And this gives the funding team a very good budget to aggressively push for adoption. This both with marketing, but also by paying people to use your network. I mean, it's very common that like those blockchains, they give grants for companies to use their products. So companies that wouldn't really care about using their network, they end up doing so because there are like they have free money to do so. So yeah, that's also a driver of adoption. And also, yeah, there is a DeFi and like other kind of gambling tools that are quite popular, and they can drive demands in this kind of networks. So can we have a Bitcoin-based alternative? So the point is, altcoins, they can be good for some market participant, but they are not good for all market participants. So can we have a Bitcoin-based alternative that can truly be an alternative, can truly offer something different, and can truly meet the needs of market participants that today don't have their needs met? So first of all, let's have an understanding of what we want, what we don't want. So what we don't want. We don't want to trust a federation, because if we introduce a federation, then basically is not that much different from like an altcoin with a bunch of proof-of-stake validators. So it doesn't really change the trust trade-off around. So we don't want to introduce a federation that we need to trust. We don't want to trust a small set of validators, of proof-of-stake validator, because that's like low. It implies a low level of decentralization, easy censorship, and all this issue that we already discussed. We don't want to be hard to run your own node as a user, because if it's hard to run your own node as a user, then you need to trust an external indexer. And if there are there will be few external indexer, because not many people want to run an indexer, and this means that everybody needs to trust those few indexes that can lie, be unreliable, that can crash, that can run out of business. So many things can happen that we want to avoid. And we don't want uncertainty on long-term reliability, as we already discussed. So what is the solution available to provide a real alternative? The solution is provided by RGB, is to use the framework of client-side validation, which has several advantages. First of all, it it decreases the cost of validation and running a node, and improve privacy at the same time, because the transaction information is not published on a global ledger, and they're only shared between peers. So what does it mean? It means that each user only needs to see and validate the transactions that are relevant for his wallet, for his portfolio. And this means that we achieve at the same time like a good level of privacy, low cost of running a node, and so we don't impact the decentralization of the network, and so it's like even low consumer grade hardware can run on it. And so this achieve our goal to not having to rely on third party, and also like as a side effect, we also have extra privacy that is always good. RGB is built on top of Bitcoin, but on top of Bitcoin, actually, I could even say is built inside of Bitcoin. So each RGB transfer is committed inside a Bitcoin transaction. So this means that we don't introduce any extra trust assumption when we use RGB compared to when we use Bitcoin. So what is the trust assumption that we have when we use Bitcoin? The trust assumption is that no more than 51% of the global hash rate of all the miners is controlled by a single entity. Because if more than 51% of the hash rate is controlled by a single entity, then censorship and double spending can, like a long reorg that can lead to double spending can happen. So when we use Bitcoin, we have this assumption: not more than 51% is controlled by a single entity. And we keep this assumption with RGB, because we don't introduce any extra layer of trust. We just have RGB transfer committed inside a Bitcoin transaction. So once the Bitcoin transaction is confirmed and receive a sufficient amount of confirmation that we believe that there won't be a reorg, then we can be sure that also the RGB transfer cannot be double spent as well, and cannot be censored as well because of the same assumption. So we have this protocol running directly inside of Bitcoin without adding extra layers of trust, and without increasing the validation cost for the network participant. Because anyone that doesn't run RGB, that doesn't care about RGB, will not even notice that RGB even exists. Because those will be just normal Bitcoin transactions that you don't even understand that they are in any way related to RGB. So you don't ask nodes on the Bitcoin network like, oh, please validate this extra stuff related to the RGB protocol. No, the Bitcoin nodes don't need to do that. And even the RGB aware wallets, they only validate the stuff that is relevant to them. So only about the assets that they're interested in, and more specifically about the transaction that they're interested in. So there can be a lot of activities happening with RGB, but each user will have to validate only a very small fraction. So the overall cost of running this in terms of resources on your hardware will be almost the same as what you have with Bitcoin. You just will have, of course, a little bit more because you look a little bit of extra stuff, but just slightly more, almost the same as just running a Bitcoin node. So in this way, basically, we achieve all the good properties of Bitcoin compared to altcoins. So Bitcoin has good guarantees of decentralization because it's based on proof of work and not on proof of stake. Because it is the mining ecosystem is actually quite well decentralized. I mean, people may complain that it could be more decentralized, but still there is nothing better than Bitcoin on that point of view. So it gives you the best security guarantees that you can have in compared to any other alternative. The cost of running a node on Bitcoin, we could complain that it could be even better, but still is much lower than any other chain that has a similar volume of transactions. So you can run your own Bitcoin node on your hardware. You have a Bitcoin node on my consumer grade laptop, and probably and you can run Bitcoin nodes on cheaper laptops than this one without too many issues. So we achieve all the good properties that we have. On top, we don't need to introduce any extra token, because when all those altcoins, they have their own extra native token that often was issued through an ICO process, that also from a legal point of view, there can be a little bit of uncertainty if there are like a legal and compliance implication in using such chains. You don't have that with Bitcoin, because with Bitcoin, you only need the Bitcoins to pay for transaction fees. And the same is for RGB. There is no RGB native token. You just use Bitcoins to pay for transaction fees when you need to do an RGB transfer. The way we achieve all of this is also that we use the blockchain only for the thing that we really needed, which is protection from double spending. We do not use the blockchain as a data availability layer, meaning that we don't put we don't encode the information of an RGB transfer inside a Bitcoin transaction, but inside that Bitcoin transaction there is only a commitment, like to simplify a lot, let's say an hash of the RGB transfer. So we don't even annoy people running a node with extra data that they don't care about, because we don't put those data on the blockchain, but we keep them outside client side. So the data related to the RGB transaction are transferred only between the payer and the receiver of a payment, not shared globally with all the users. So in this way, we achieve all the good properties that we just discussed. So this is a slightly more technical slide, but to give you a bit more of understanding on how RGB actually works. So let's say that I want to issue a token, just red token, just a generic token. What I do to issue a token, I create the issuance contract, which you can think like it's a contract, or like generalize as a simple message that just encodes the information about the asset and the contract itself. So for example, I say, okay, what is the name of the asset? What is the ticker? The total supply? The contract may also encode some validation rules, so now you can transfer the asset around. And then you define who is the first owner of all of those tokens. And ownership in RGB is defined as whoever controls a certain UTXO. So the owner of the asset is not a public key, is not a person, is not a signature, it's a Bitcoin UTXO. So I issue a contract, say I'm creating 100 units of this red token, and those 100 units initially will be owned by UTXOA. So that is just an output on the Bitcoin blockchain. This output is controlled by someone. Either it can be just a single signature output, or can be like a multi-sig, so actually more people are involved in controlling this UTXO, or it could be some more complex smart contract that you can build with the Bitcoin scripting capabilities, but it doesn't really matter. All we care about is that the owner is whoever is the owner of UTXOA, whether it is one guy or multiple people, or multiple people depending on the different conditions. So we have the first owner of our token. Now, how can ownership be transferred? So to transfer ownership, an RGB transfer, the ownership transfer, basically, to simplify, encodes the information that this token that previously were owned by UTXOA, from now on will be owned, part of them by UTXOB and part of them by UTXOC. So we see this an example, and realistically we can imply that owner of UTXOA is sending 20 units to the owner of UTXOB, and then is sending 80 units as a change to himself to another UTXO that he has in his wallet. So at this point, we have these 20 units that were involved in the payments that are transferred to UTXOB, and this ownership transfer that move from A to B and C are committed inside a Bitcoin transaction. So to simplify, the hash of this message that say the token move from A to B and C is inside the output of a Bitcoin transaction, but not any Bitcoin transaction. It needs to be the Bitcoin transaction that spend UTXOA, because in this way, by spending UTXOA, you can prove that you are actually the owner of UTXOA. As a consequence, the owner of this token, meaning that you have as the owner, you have the right to transfer ownership to someone else. So yeah, now then, and this cycle then can go on and on forever. So now these tokens are controlled by UTXOB. UTXOB send like 6 of them, say, okay, this 20 tokens that now are controlled by UTXOB. From now on, 6 of them will be controlled by UTXOD and 14 by UTXOE. And this is committed inside the Bitcoin transaction spending UTXOB. And then, yeah, the chain, or actually, yeah, now we're just looking at the chain, but then it's more like a graph, because also UTXOC will spend and UTXOD, like it just expand at any time that there is a payment. So yeah, in this way we have a transfer of ownership linked to a Bitcoin transaction. Every transfer of ownership is committed inside a Bitcoin transaction. Once this Bitcoin transaction receives a sufficient amount of confirmation on the Bitcoin blockchain, we can be confident that the RGB transfer cannot be double spent, cannot be reverted, and this can be considered final. But yeah, all of this that we saw is just on-chain, and on-chain is not really interesting because you need to pay a lot of transaction fee, especially when there is a lot of activity on the network, and also you need to wait for block confirmation that can be quite annoying depending on your use case. So to make this actually interesting, we need compatibility with layer 2, and yeah, the only layer 2 that today is available on production on Bitcoin is the Lightning Network. So how can we achieve compatibility with the Lightning Network? So it is possible to modify an existing Lightning node to support RGB assets, or like to create a new Lightning node to support RGB asset. And once you have that, you are able to create Lightning channels that, instead of being denominated in Bitcoin, Satoshis, they're denominated in an RGB asset. There can be like, yeah, any RGB asset that you issued. You can create Lightning channels that are denominated in this asset, meaning that I can transfer RGB tokens through Lightning channels or across Lightning channels, also doing routing, with the same speed and convenience that you move Bitcoin on Lightning. With also, yeah, the same usability trade-off. So yeah, if you're saying that yeah, using Lightning sometimes can be not super user-friendly, then you have the same here, but you also have the advantages that you have very low fees. You don't need to wait for confirmations. You have good privacy because your information is not published on a global ledger or on the blockchain, and yes, so all the good reason why people like to use Lightning. So we have the same trade-off on Bitcoin Lightning. It's exactly the same. It's not worse, it's not better. It's exactly the same as using Bitcoin on Lightning. It's just that instead of moving Bitcoin, we move something else. And of course, yeah, we require liquidity to work. So yeah, whoever ever tried Lightning knows that he needs to have some outbound liquidity, inbound liquidity to be connected to a bunch of peers. So yeah, you can do this with assets that are popular enough that realistically can get some good level of liquidity. Good news in that you can already try this in practice. It's not theory. So there is our team in Bitfinex worked on this Lightning node that is able to create Lightning channel denominated in RGB asset. So yeah, it's called RGB Lightning node. So if you want to look at it, it's freely available on GitHub. So yeah, it is already possible to do so. The cool thing is that once you have a DEX on top of Lightning, we have an asset on top of Lightning, then you can create a DEX on top of Lightning. So what does it mean? Right now on Lightning, we only have Bitcoin. Once we have Bitcoin and something else, let's say like a stable coin like USDT, then you can create atomic swaps between Bitcoin and USDT. And this works very elegantly because if you think about the routing on Lightning Network works, basically you already do swaps on Lightning Network when you do routed payments. You swap Bitcoins that are in one payment channel for Bitcoins that are on another payment channel. But the thing is that we consider those Bitcoins fungible with each other, so we don't need to agree on an exchange rate for Bitcoin in one channel and Bitcoin in another channel. because it's always Bitcoin, it's all the same. But still, there is this kind of swapping mechanism. Like I'm giving to the guy that is doing routing, I give you some Bitcoin, and in exchange you give other of your Bitcoin to another guy. So the only thing that we actually change is that we have multiple assets. So I give you Bitcoin, and instead of just giving other Bitcoins to someone else, you give another asset to someone else. So there will be one guy in this example, this guy here, that is receiving Bitcoin and sending USDT. And if we make it circular kind of payments that start from like one person, go back to the same person, then we operate the de facto a swap between, let's call them Alice and Bob. So this is Alice and this is Bob. So Alice and Bob, basically they made a swap because Alice gave away Bitcoin and received the USDT, while Bob received Bitcoin and gave away USDT. And the people in the middle, they just did the routing for their respective asset. So this guy in the middle, all they know is that they did routing for some Bitcoins. They have no idea that there is a swap in the middle. They may not even know what is RGB. They just did the routing for Bitcoin. And this lady below, she did some routing for a USDT payment. She doesn't know that there is a swap involved. So we have very good, only the two people involved know that this trade even happened. So the only extra complexity that we introduce is that Alice and Bob need to agree on exchange rate. So while let's say, and probably Bob will say, okay, I'm willing to buy your Bitcoin for I don't know, 68,000 USDT, and if Alice agree, then they operate the swap, and it's atomic because like payments on Lightning, either it goes through completely or it fails completely. So if something goes wrong, this wall swap will just not happen at all. And if everything goes well, it goes through, but there will never be a case where Bob received the Bitcoin, but Alice never received the USDT or the other way around. Because of the way Lightning works, payments on Lightning are atomic. They either go through or they don't. And for the same reason, swaps on RGB on Lightning, they are atomic. Either they happen or they don't. So there is no need to trust your counterparty or to trust any escrow that will have to facilitate the transaction. There is no escrow, there is no third party, it's just the two people that operate an atomic swap with each other. And this gives us several advantages. There is no on-chain fees because everything is on Lightning. There is low latency, especially in the case where two people may have direct channels with each other. So, but more importantly, in any case, you don't need to wait block confirmation. That can take a while. There is privacy and no front running. It's like when you use DEXes on Ethereum, miners can front run you, Flashbot can front run you. So it's actually quite bad for the trading experience. With this, nobody knows that this trade is happening. Other people on the Lightning Network don't know about it. Miners even less. Nobody knows that this trade is happening, so nobody can use this information against you. Nobody can front run you. Nobody can try to extract value from your trade. And also, there is certainty on the execution price because we agree upfront on what is going to be the price at which we exchange the two assets, and it's not a market order like when you use liquidity pools on Ethereum. So there are several advantages in this design compared to what we have right now with like automated market makers pools on EVM chains. And the good news is also, this morning, like there is already a software that support this. This morning, the KaleidoSwap team also gave a little presentation. So if those that were there, they already know. So there is this first like an MVP, a prototype, but you can already try out to do swaps on top of Lightning between RGB assets. So now also I would like to talk a bit more about what the Bitfinex team working RGB actually is doing and did, because it also relates on the general team of people building stuff on top of RGB. So the goal of our team is just to facilitate the development of the RGB ecosystem. So it's not like we are particularly business or product oriented. So for this, we contribute to the protocol itself with PR, testing, bug fixing, improvement proposal, etc. we build numerous developers tools because, one issue with RGB is that it's a very new technology. It's very different from everything else. If you are a dev coming from Ethereum, even from Bitcoin, even coming from Lightning Network, it will take time to actually understand how RGB works. So we build tools that remove this requirement. So thanks to the tools that we developed, the most relevant of which is the RGB lib, that you can check it on our GitHub, RGB tools, our GitHub organization. If you are a wallet developer, you don't really need to understand how RGB works and all the implication involved in an RGB transfer, in UTXO management and such stuff, because the libraries takes care of all of this complexity for you. So we reduce the friction for our wallet developers to start building on top of RGB. And this is very important because, we by building our library, we saw how much complexity we had to deal with. And so we decided not to just do the job only for ourselves, but also do it for everyone in the future. So we can, so it will be much faster for developers to build stuff on RGB. And actually, we already have a bunch of teams that build or are building their products leveraging our developers tools. We released a wallet for Android that you can try. Later we will talk more about this. We build the RGB Lightning node that we discussed about before, which, by the way, for those who are familiar with it, is based on LDK. So it's the most all the Lightning logic was not built from scratch, but we just leveraged all the amazing work from the LDK team. And we also try to support other teams that build on RGB because we really care about the more people building on top of RGB, so the ecosystem can truly develop. So we the wallet that we also released a wallet. First of all, for us also to be a first user of our library, but also to have a place where both us and our user can experiment easily with RGB. If you have for the mobile version, if you have Android, you can download the Iris wallet from the Play Store, or if you don't want to use the Play Store, you can go on our GitHub and download the APK. So this version is on-chain only, but you can issue asset, transfer, receive asset, and do all the kind of stuff that you can do with RGB, both with fungible asset and collectible assets. Now we also worked on the desktop version of Iris Wallet, which supports also the Lightning Network. So while on mobile, Lightning on mobile is still a bit tricky and will take more time to have it. Now on desktop, it is possible to use RGB on Lightning from like a fairly simple user interface. At least, I mean, you don't need to use the command line, but you can interact with a user interface. So now what we will do, instead of just showing you a screenshot, we will actually try to use the app itself so you can get an understanding on what is the user experience of using RGB on Lightning. So what I did, I already have two wallets on my computer, and we will do some transfer between the two of them. So now these wallets are running on RegTest, so we can have faster block confirmation without having to wait for actual blocks to confirm. So the both wallets, they already have some Bitcoin balance. On RGB, you always need to have a positive Bitcoin balance in order to pay for transaction fees, and also to have a bunch of UTXO that you can use to receive, to issue asset or to receive your assets. Maybe what is the first thing that you want to do? You want to issue some asset. So here you can issue a collectible where you just provide the name, some asset description, total supply, and then you upload a file if you want to have like kind of a NFT-like experience, or you can issue a fungible token, which is something like stablecoin, stuff like that, or like utility tokens, so security token, where also here you can provide a ticker. So let's do it like in the slide before with this generic red token with some kind of supply, say 1,000 units or whatever. And yeah, as you can see, the issuance is very, very fast because we don't need to wait for any on-chain confirmation. The issuance happen off-chain, so it's immediate. Right now, I already have the assets. No blockchain events need to happen. It's just yeah, I just issue the asset. Then yeah, only when I transfer it, then we will have to wait for blockchain confirmation. Then yeah, if we want to transfer some tokens, say yeah, oh no, it was on the other side. So the counterparty will have to provide an RGB invoice where they can receive the asset. So here I'm copying this RGB invoice, or I could scan the QR code if I was on a mobile environment. And here I send, in this case, on-chain, because we still didn't open a Lightning channel for this asset. I paste the invoice. Yeah, I specify an amount because the receiver didn't specify, so I need to do it myself on the sender side, and I send. So success, the asset was sent. So you see my balance went down by 10 units. And on the other side, I received 10 units of the token. So yeah, now it's waiting for confirmation, and yeah, soon in the reg test environment, like yeah, is mining quite fast. So yeah, it should receive confirmation quite well, quite yeah, faster than it will take normally on mainnet. But yeah, on chain, as we say before, is not so interesting. The real interesting part is Lightning. So in this case here, we already had I already had issued an asset before, and for this fake USD, we had already opened a Lightning channel. So we can. It means that this wallet can already ask to receive off-chain this asset. So let's say that I want to receive 100 units. I put some expiration time for the Lightning payment. And I have my Lightning invoice. Now I go on the other wallet, and I want to pay someone using this asset. So I send off-chain. I paste the Lightning invoice. I confirm. The channel might be close. Okay, this was unexpected. So yeah, let's maybe. Sorry? I tried to transfer too many. Yeah, wait, maybe because. Okay, let's. So yeah, should do it with less assets, right? Yeah. So yeah, let's try to again. Yeah, okay, yeah. To. Yeah, let's make it simple. Okay, send, chain. Okay, went through. So yeah, you see, like RGB doesn't let you spend more money than you can. So it good that he gave me an error. Okay, so yeah. So yeah, we have a Lightning payment on RGB. So yeah, this is quite cool. Yeah, we can maybe also try to open another channel to see also what is the experience with that. So yeah, when I create a channel, I need to provide the counterparty node. So where you can find the node info here under about. So I paste it here, and I also need to provide where it is. Now it's on the same machine, so I can do it with localhost, and the port is this one. Next, then I need to specify the asset. So yeah, let's open with the new asset. I don't remember. Yeah, let's put as Roma. I don't remember how much I had. Capacity of the channel, here you need to say how much Satoshi I want to put in a channel, because you still need to move a small amount of Satoshis around for the channel. This actually could be abstracted away, but yeah, this is a first prototype, which is a bit more for power users. But yeah, let's say 40,000, it's enough. Push amount, I can leave it 0. So yeah, channel successfully created. We can see now in the list that I have another channel for this other asset ID. Status is still pending because I still need to receive confirmation. Let's look on the other side. I also here see it pending. And yeah, I guess it needs to receive 6 confirmation, which shouldn't take too much because it's in background running mining nodes every few seconds, but yeah, still needs some time. So yeah, this is pretty much it. So we made an on-chain payments. We need a Lightning payment. We open the channel, and yeah, kind of works. So if you want to try this, it's not public yet, but what we will do is that so we have a Telegram channel for Iris Wallet, and we will publish the app image for Linux on this Telegram channel. So yeah, you can join the channel, and yeah, right after this talk, we will publish the app image, so you can try it on your own Linux machine. If you have something else, yeah, you will need to wait a bit more that we support their platform. So yeah, thank you so much, and yeah, this is the end of the talk. I think yeah, we can collect a few questions. So yeah, maybe we can start from yeah, we have a mic, so yeah, okay, perfect.
Hi, I would like to ask, so on the Lightning Network, there is no blockchain analytics. So you cannot, there are no addresses, there's no blockchain, so you cannot really trace the transactions. How about with the RGB blockchains? Would it be possible to apply blockchain analytics on the RGB transactions, like to trace them back, to find the illicit actors, to identify the users? Thank you.
So on RGB transaction on Lightning, I mean, it's the same as Lightning. So so yeah, the same level of you get the same level of privacy. On RGB on chain, also like chain analysis cannot do much. Maybe they could try to use some heuristic to try to guess if there is transaction that's involved with RGB, but yeah, it will be quite weak. So yeah, chain analysis, I don't know, maybe they will come out with something else, but yeah, current chain analysis technique are not particularly effective. They're almost ineffective on RGB.
Maybe I didn't follow you at the beginning. Where's the contract information stored at the beginning? I mean, you created UTXO. After that, I did understand, but the
no, actually, it's a good question. Yeah, like I didn't go too much into details on this part, but basically, yeah, every time we do an ownership transfer, we share a bunch of data. So the payer share a bunch of data with the receiver. So it doesn't only share data about this transfer itself, but also shares data about previous transfer and about the issuance contract. So so this way the receiver can get all the information and can say, okay, this is the issuance contract. He had these validation rules, and then he can try to apply those rules to all the transfer to validate that everything is correct and everything is valid. So the issuance contract is by default shared with transfer, but then on top of that, the issuer may decide to share it on some public platform like a website or whatever, so other people can look at it even before receiving any token.
But it's not stored on the Bitcoin.
It's not stored on chain. It's only stored on the device of the issuer, of the people that receive it, or people that found the information somewhere online.
Okay, thank you very much.
Yeah.
Ciao. When you say RGB needs liquidity in order to work, what do you mean exactly?
I mean the same liquidity that you need on Lightning with Bitcoin.
The liquidity of the nodes that are involved.
Yeah, just the nodes need, you need to have inbound liquidity, outbound liquidity. You need to have found people that can do routing for you. I mean, this kind of stuff. So yeah, the same that you have with Lightning.
The same with Lightning. Thank you.
Just to continue the question, the fees on Lightning Network are paid with token or in other way?
Yeah, are paid now with bitcoins, but yes, more on implementation stuff. Like in the future, theoretically, you could also make it pay with token if the people agree with it.
Okay, so I need a token that is fungible as much as Bitcoin, not, for example, a finite number of finite supply.
I mean, you can pay with any token. Then, of course, people will be more happy to accept tokens that are very fungible. But if they are willing to accept something that is not particularly fungible, they can do that from a technical point of view.
If I understand correctly, there is a sort of second Lightning network of channels of the token. Is it right?
Correct, yes. So basically, it's like a separate network for each token.
Okay, and what happens in case of force closing the channels? Thank you.
The same thing that happens with Lightning when you force close a channel. So it's exactly the same behavior. So yeah, if you force close a channel, the channel will close. There will be an on-chain event, like you do when you use.
The asset goes on chain.
The assets are settled on chain, so they go to the UTXOs of the two party for the amount of the last state of the channel.
Thank you.
Yeah, hey, for the DEX, how do you ensure the liquidity, that there is enough liquidity on DEX? Or for example, if I understand correctly, it's kind of more peer-to-peer exchanges on the DEX, but
well, I mean, yeah, it's like market driven. So yeah, if there is a demand for trading, it means that people will be willing to pay maybe like a spread, and it means that will be people that are willing to provide liquidity. So the idea is that the expectation is that there will be people that are kind of like a market maker. So they are offering to exchange like a Bitcoin for USDT or whatever other asset for a price that is maybe like slightly higher than on centralized exchanges, and then they can either hedge or run their own strategy to make it profitable to provide the liquidity to the market.
If possible, another question. As tokens that created on the RGB, they exist both on the native BTC network and on Lightning network. So
yeah, I mean, like they are born on chain, like they are born on a Bitcoin UTXO, and then they can be added to Lightning channels later on through. So basically, you will do a transfer like this that sends to an UTXO that is the Lightning multisig UTXO.
What about the supply? Like, that's the first question. For example, if there in the middle of this transaction the supply changes, how does it actually work? This is the first. And the second question is, what about the ability of issuer of the token, specifically Tether in our case, ability to block or lock, hold, like freeze some UTXO, like we have now in all the chains. Even in Omni-chain, if I'm not mistaken, there is also possibility right now to lock specific address with the amount of USDT. Yeah.
So regarding the first question, it's possible to increase the supply through a secondary issuance. So what will happen is that like from here, basically there needs to be an UTXO that has the right to create to do secondary issuance in the future. So this right needs to be defined at the beginning, and this means that there is an UTXO that the contract define, okay, UTXO, I don't know, X has the right to do at a future point another issuance, and at that point then you can spend UTXO X to increase the supply, and users will recognize this new supply as valid because the issuance contract said that this was a possibility. No, it's gonna sit on a new UTXO. So also because probably this UTXO has already been spent in the meantime. Okay. So there is gonna be like a new UTXO. And the important question in the next. Of course, like this is gonna be a bit more tricky in RGB compared to how you do it on chain. But something that like issuers could do is that they may decide if certain Bitcoin output that they don't like are part of the history of transaction. They may decide not to accept not to allow redemption, or I don't know. They can employ other strategy, but yeah, it's gonna be more challenging to just block an UTXO. So yeah, I mean, I'm not aware of anyone that already came up with a specific strategy, but yeah, it's possible to do something, but it's not gonna be as easy. So yeah, maybe yeah, if you have your own.
You can't block, but you as an issuer may not accept this in the future if it passes.
Yeah, indeed. So like, yeah, for example, yeah, the value of Tether comes from the fact that you can redeem. But if Tether say, okay, I'm not gonna redeem anything that went through the North Korea, that was in the past owned by the North Korean hackers or whatever, then yeah, those USDT that don't really have value because they cannot be redeemed. So this can be a strategy.
Similarly, we have now, like, in addition to this mechanism, there is mechanism to specifically freeze specific address.
Yeah, no. So yeah, freezing a specific address is.
So if I understand you correctly, there is no way to freeze any UTXO using this.
Well, I mean, you can maybe publish the fact that a certain UTXO is considered frozen, and so wallets can be aware of this and try not to accept anything coming from that UTXO, which is de facto frozen. Yeah, but then you need to enforce wallets. So I mean, yeah, I think adding layer of complexity probably, yeah, it could be achieved, something close enough. But yeah, it's not as automatic as it is with on-chain freezing.
And I arrived a little bit late, so maybe I missed some information. But all the information is sitting on the Bitcoin blockchain except for the issuance contract.
No, actually, on the Bitcoin blockchain, we just have commitment to transfer. All the information about transfer is shared between payer and receiver at every payment.
Outside of the blockchain?
Outside of the blockchain, like through direct communication channel between the two wallets.
But UTXOs are still moving, being spent on the Bitcoin blockchain.
Yes, but what is outside of the blockchain is like the message, red token, 20 red token have been moved from A to B. This message is not on the blockchain. This message is outside and is shared directly between the two wallets.
So that's an extra software that you need to run that's kind of peer-to-peer where you're directly getting the information. Is it shared anywhere? Or is it like broadcasted anywhere, or is it like local?
Well, I mean, RGB is quite, like the protocol itself is quite agnostic to that. So like it doesn't really care, just care that somehow the receiver get the information. So now the way we've been implementing so far is that it's just share peer-to-peer between the two wallets. But nothing stop wallets to put it somewhere public, available to everyone if they want to. But it's optional.
So it doesn't have to be broadcasted.
They can broadcast it on somewhere if they want.
So the Lightning node is kind of part of the same software. You just have to run one extra software.
Yeah. This is like a Lightning node that is inside as all the RGB capabilities.
Next to the
also both on chain, off chain. So yeah.
Thank
you. Is there a way to make it impossible for the issuer of a RGB token to modify the supply and prove that?
The issuance contract needs to say that it's not allowed to modify the supply. So at the beginning, the issuer can restrict himself from modifying the supply in the future, and maybe something that it's necessary to give value to the token. So if the market requires so, the issuer will be forced to restrict himself at the beginning so that people buy the token.
Now, how do you restrict yourself?
Yeah, in the issuance contract, here is simplified, but you can say you can say the condition: can this issuer do a secondary issuance, or he can't? If he say he can't, then he cannot do it. I mean, if he tries to do it, will be invalid through the validation process. So.
Okay, thank you.
Okay, are we good? Great. So yeah, thank you so much.